We're going to talk more about number theory and divisibility. In the last video, we introduced factors and multiples and divisible. And sometimes things are really easy. Like, is 12 divisible by 4? And the answer is yes, because we know that 12 divided by 4 equals 3. All right, this one we could do because we already knew the answer. Now, is 210 divisible by 3? Now, that's probably not one you have memorized, so there's always two options. Option 1, you do the long work until you find the answer and say, yes, it is divisible, or no, it's not divisible. You can always do that, but we want to see if we can come up with quicker ways to determine if things are divisible. So, I know that 210, I can write that as 21 times 10, and I know that 21 I can write as 3 times 7. So 3 times 7 times 10 is 210. So is it divisible by 3? Yes. And specifically, I know that 3 times 70 is equal to 210, or that 210 divided by 3 must then equal 70. Now, let's try this again in a slightly different way. Is 210 divisible by 15? Now, a 15 is made of a 3 and a 5. So if I were to think of 210 as equaling 3 times, I'm going to go back to this last step, which was 21 times 10. I know this is equal to 3 times 5. I know there's a 3 in here and a 5 in here, so this could be 7 times 3 times 5 times 2, which is the same thing as, well, that's a 15, 3 times 5, so this is 15 times 7 times 2, or 15 times 14. So is it divisible by 15? Absolutely, because 15 is a factor. So 15 times 14 is equal to 210, or 210 divided by 15 equals 14. So yes for here, yes for here. Now, let's try another one. Is 1,205, is that divisible by 15? So then we'd have to think about it. And it's like, well, this ends in a 5. So I know that it's divisible by a 5, because, right, 15 is equal to 3 times 5. So the idea is, if I could say this is divisible by 5 and divisible by 3, well, then I know it's got to be divisible by 15. So, we, in this video, are going to come up with other methods of figuring this out. So, how can we check divisibility without doing long division, right? This first step up here, where I could have said, we could have done long division to figure out the answer. I didn't do it because I want to see if I can come up with quicker ways of doing it. And these are the divisibility tests. So, how do we know if a whole number is divisible by 1? And the answer is all whole numbers are divisible by 1. How do we know if a whole number is divisible by 2? And we can just say it is even. Right? All even numbers are multiples of 2. So any even number is divisible by 2. Now, how do we know if a number is divisible by 3? And this is the divisible by 3 rule. See below. So we can come back here in a moment. The divisible by 3 rule says to figure out if a number is divisible by 3, you add all the digits. Then if the sum is divisible by 3, then the original number is divisible by 3. So 210 was divisible by 3. If I were to add the digits, 2 plus 1 plus 0, 2 plus 1 plus 0 equals 3, and 3 is divisible by 3. Another example, 252. 2 plus 5 plus 2 equals 9. And 9 is divisible by 3, so therefore 252 is divisible by 3. That doesn't tell me what the answer is, but it tells me that I would get a whole number answer with no remainder. Now, why does this work? Why can we just add up the digits and see if that sum is divisible by 3? And it goes like this. 9 is divisible by 3. 99 is divisible by 3, right? 3 times 9, 3 times 3, 3 times 33, 999 is divisible by 3. So we use that fact, along with the fact that if A is divisible by 3 and B is divisible by 3, then A plus B is divisible by 3. So, for example, 9 is divisible by 3, it is 3 times 3. And 15 is divisible by 3, that is equal to 3 times 5. And now I can factor, which makes this 3 times 3 plus 5, right? It's the opposite of the distributive property. And 3 times 3 plus 5, this is the same thing as 3 times 8, right? When 3 is a factor of both terms, you can factor it out, and therefore it must be a factor of their sum. So, if two things are divisible by 3, their sum must be divisible by 3. So let's take a look at this, right? I'm going to use these ideas right here. 252. That is the same thing as 100 plus 100 plus 10 plus 10 plus 10 plus 10. 2, 3. I think I need another 10 plus 2. But each 100 has a 99 and then a 1. So we get a 99 and a 1. And we get a 99 and a 1. And we use the fact that 9 is divisible by 3. So we get a 9 and a 1 for this 10, and a 9 and a 1 for this 10, and a 9 and a 1 for this 10, and a 9 and a 1 for this 10. And that's 1, 2, 3, 4, and I need another 9 and a 1. And then I have my 2 1s. So really I'm just splitting my hundreds into 99 plus 1, and each 10 into 9 plus 1. Now, I'm actually going to rearrange and group these, so this is the same thing as I have a 99 and a 99, plus we have a 2. And then I have a 9 plus a 9 plus a 9 plus a 9 plus a 9. And then I've got 1, 2, 3, 4, 5 1s. And then I have my 2 left over. And so what we can see is we know that the 3 can go into all the 99s, and we know the 3 can divide into all of the 9s, and so all we have to do is add up the little bit that was left over, which is the 2 1s that were left over here, the 5 1s that were left over here, and then the 2 that were remaining. So for every 100, we get 1 left over, so that's 2, and for every 10, we get 1 left over, which is 5, and then we have the 2 1s. And we already know that the 3 goes into all of this stuff, so we just have to figure out if the 3 will go into this stuff. All right, another visual. Base 10 blocks, 252. So this is a 100 block, a 100 block. These are the 10 rods, and these are the 1s. Now we already know 100 could be thought of as 99 and 1. And all of these could be thought of as 9 and 1 and 9 and 1. And 9 and 1, and 9 and 1, and 9 and 1, and 1 and 1. And we already know that 3 will divide into all of this stuff. And so all we have to see is if 3 will divide into the remaining 1, 1, 1, 1, 1, 1, 1, and 1. So for every 100, we take 1. For every 10, we take 1, which really means we just add up, right? What was the rule? Add the 2 plus the 5 plus the 2. So let's try this. Is 1,205 divisible by 3? Well, we add 1 plus 2 plus 0 plus 5, and we get 8. And is 8 divisible by 3? And the answer is no. So if I went back to the original problem, which was, is 1,205 divisible by 15? Well, it's divisible by 5, because this ends in a 5, but it is not divisible by 3. And that's what we just saw, so no. All right. So that was divisible by 3. Now, how do we figure out if something is divisible by 4? Now, a number is divisible by 2 if it's even. A number divisible by 4 must be divisible by 2 twice, because 4 is equal to 2 times 2. So if you divide out a 2, you have to divide out another 2. They oftentimes refer to this as being doubly even. A number is even. After you divide out 2 and cut it in half, it is still even. And so what that means is, pardon me, if we had 4 times A to get B, 4 is the same thing as 2 times A to get B. So that means if B is an even number, I can divide out a 2, and what I'm left with is still even, which lets me take out another 2. It's called doubly even. it's divisible by 2 twice. Cut it in half, take an even number, cut it in half, it's still even. So let's try this real quick. It says, is 128 divisible by 4? Well, you can take, because usually it's easy to cut numbers in half. So 128 divided by 2 is 64. So it was even once, so we could cut it in half. And now 64 is also even, so we can cut it in half again. Or another way of looking at it is 128 equals 2 times 64. But 64 is equal to 2 times 32. And I can put those two 2's together to get 4, so it would be 4 times 32. So yes, it's doubly even. It would even be triply even, because I could take out another 2. And that would let it be divisible by 8, which will be the divisible by 8 rule. It is triply even. You can take out a 2, or factor out a 2, or divide by 2 3 times. So, next question. Is 210 divisible by 4? Is it doubly even? So, 210. We can cut it in half once. It's even. And we get 105. But 105, is that even? And the answer is no. This is odd. So you cannot cut it in half evenly. So you cannot take out another 2. So the answer is no. This thing is not divisible by 4. All right. Now we're going to start putting together some of these ideas. How can I tell if a number is divisible by 6? And the answer is it is divisible by both 2 and 3, right? If I take a number 6 times a to get b, well, that's the same thing as 2 times 3 times a to get b. So that means I could take b, it must be divisible by 2, and it must be divisible by 3. So if I know it satisfies the divisible by 3 rule and it is an even number, it can be divisible by 3. So for example, 252. When I added up all of these numbers, right, 2 plus 5 plus 2, I got 9. So this thing was divisible by 3, but it's also an even number, so it's also divisible by 2. And if it's divisible by 2 and 3, it must be divisible by 6. So I could say 252 is divisible by 6. All right. How do we tell if a number is divisible by 9? And this is the same rule and reasons as divisible by 3. If the sum of the digits is divisible by 9. And that's because 9 is divisible by 9, 99 is divisible by 9, 999 is divisible by 9. So I could say, is 252 divisible by 9? And so all I do is say, well, I know 99 is divisible by 9, so for each 100, I have 1 left over. For each 10, I have 1 left over. And then I've got my singles, right? So I already know that this stuff is divisible by 9, and this stuff is divisible by 9, and all of this stuff is divisible by 9. So really, I just got to check, is the last little bit still divisible by 9? So we take the 2 plus the 5 plus the 2, and that equals 9. And 9 is divisible by 9, so yes. It doesn't necessarily tell us what the answer is. It doesn't say what we get when we divide 252 by 9, but we do know that it is divisible by 9. Now, is 1,234 divisible by 9? 1 plus 2 plus 3 plus 4, that is 4, 5, 6, 7, 8, 9, 10. This equals 10. And is 10 divisible by 9? No. But what this can let me do is create numbers that are divisible by 9 that are really, really, really big. Like, I know if this added up to a 9, it would be, so I could even make this a 1, 1, 3, 4. I don't know why I put it in a second comma in there. Because 4 plus 3 is 7, plus 1 is 8, plus another 1 is 9. Those all add up to 9, so yes. So I can create numbers that must be divisible by 9. Now, go ahead, take your calculator, do long division, and you can see what you get when you divide them, but it should go in evenly with no remainder. All right, so let's take a look at this. How do we know if a number is divisible by 1? All numbers are. 2, it's even. 3, divisible by 3 rule. 4, it is doubly even, right? You can divide by 2 twice. 4 equals 2 times 2. Now, sometimes it is hard to cut a giant number in half. For example, one of the ones we're going to do is this. Is this thing divisible by all of these numbers? So divisible by 4. So yes, it's even, which means we can take out a 2. But then it might actually take a lot of work to cut this number in half to see if when you cut this in half, it is also even. But we only need to actually focus on the last two digits. Because once you take off the last two digits, you get 236, 700 plus 84. And these are in the hundreds, and all hundreds are divisible by 4 because we know that 4 times 25 equals 100. So this is automatically divisible by 4. You only need to check the last two. So you really only need to focus on seeing if the last two digits are doubly even, because the rest of it will be. Number 5, any number that ends in 5 or 0 is a multiple of 5, right? 5, 10, 15, 20, 25, 30. 6. 6 is equal to 2 times 3. So this is divisible by 2 and 3, right? So you need to be both even and satisfy the divisible by 3 rule. How do we see if a number is divisible by 7? Just check. There is a divisible by 7 rule, but it is so long and convoluted. For this one, it's actually just easier to check. Now, 8. 8 is equal to 2 times 2 times 2. So this number would be triply even, which means you can divide by 2 3 times. Divide by 2, divide by 2, divide by 2. Now again, if you have a really big number, this is often very, very hard to do. So let's go back to this same problem. To take this number and cut it in half, not once, but 3 times, can be really, 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 really hard. But for triply even or divisible by 8, we only need to check the last 3 digits because 8 times 125 is equal to 1,000. So I know that if I were to take off the last 3 digits, 000 plus 784, I already know this is divisible by 8. So you only need to check triply even on the last few, which means divide it in half once, twice, 3 times to see if it's triply even. All right. So get back up here to the rules. And so for 8, again, you only need to focus on the last 3 digits for triply even. For 9, we have the divisible by 9 rule. It was the same as the divisible by 3 rule. Add up all the digits, and if the sum of the digits is divisible by 9, your number is divisible by 9. Now, there's 2 ways to do this. How do we know if something is divisible by 10? And the answer is it ends in 0. So that works. Or, now, this logic is going to help us. We know that 10 is equal to 5 times 2. So you could say it's divisible by 2, which makes it even, and it's divisible by 5, which means it has to end in a 5 or 0. But any number that ends in a 5 and 0 and is even just ends in a 0. So it's sort of putting some of these numbers together. All right, so 12. And so these next rules, we're going to be doing the same thing. So 12 is equal to 3 times 4. So to be divisible by 12, it must be divisible by 3 and divisible by 4, which means pass the divisible by 3 rule and be doubly even. To be divisible by 15, well, 15 is equal to 3 times 5. So has to be divisible by 3 and has to be divisible by 5. 18, now here's a few options. Let's see, 16. 16 is actually equal to 2 times 2 times 2 times 2. So to be divisible by 16, it'd have to be quadruply even, but I'm not really going to get into that one. It's the same thing as 2, 4, and 8. Now, 18 is equal to 2 times 9, but it's also equal to 3 times 6. Now, one of these is much more helpful. This one can cause a lot of problems because inside of this 6, there is a 3. So to say it is divisible by 3 and it's divisible by 6 is not exactly true because they would have to be divisible by 3. And then after you remove that 3, what remains still has to be divisible by 6. Otherwise, you might be counting that 1 3 2 times on accident. But since this is a 2 and there is no 2 hidden inside of 9, it is much safer to do it this way, which is to say, to be divisible by 18, you have to be divisible by 2 and be even, and divisible by 9 which means you have to satisfy the divisible by 9 rule. So we have all these rules for divisibility. Let's check them. Check divisibility. Are the following divisible by, where are we? 2, 3, that big whole list up there. So is this thing divisible by 2? Yes. I'm not even going to put 1 on here because they're all divisible by 1. Is it divisible by 3? We'll add these things together. You add this plus this, we get 7. We add on that, we get 13. 13 is not divisible by 3, so no. Is it divisible by 4? Well, let's check. Is it doubly even? So you could cut the whole thing in half, but what did I say? You only need to check the last 2. So 60 divided by 2 is 30, and this is still even, so we could do 30 divided by 2 and get 15. So yes, it is doubly even, and we only had to check the last 2 digits. Is it divisible by 5? Yes, it ends in a 0. Is it divisible by 6? Well, to be divisible by 6, it has to be divisible by a 2 and a 3, and it is not divisible by 3, so 6 goes over here. Is it divisible by 8? Well, 8 is 2 times 2 times 2, so it would have to be triply even, and we would have to just check the last 3 digits, right? So 260 divided by 2 is 130. 130 divided by 2 is 65, and 65 is an odd number, so we cannot take out another 2. And so 8 would have to go over here. Is it divisible by 9? Well, if we add all these up, 5 plus 2 plus 6 plus 0 is whatever we said, 13, and 13 is not divisible by 9, so no. Is it divisible by 10? Yes, and we already know it's divisible by 2 and 5, so therefore it's divisible by 2 times 5, but it ends in a 0. To be divisible by 12, it must be divisible by, what, 3 and 4? And it is not divisible by 3, so 12 is over here. To be divisible by 15, you got to be divisible by 3 and 5, and so check, and it is divisible by 5, but not by 3, so 15 is over here. And this one must be divisible by 2, yes, and 9, no, so 18 is over here. All right, now, in the write-up of this, I'm going to put in the next ones just for the sake of time. We're supposed to check this number and this number to see which ones they're divisible by, and I will let you go ahead and try those and then check your answers in the write-up. And that is it for this video.